All right, folks, let's go ahead and do this. This is third homework for Chapter 10. This is Chapter 10.3 homework. All right, first couple questions are just asking about vocabulary. I'll let you guys kind of look through that really quickly if you haven't had a chance. Oh, that's a lot of vocab. Good luck. Just kidding. Okay, a blank is a graphical way to display quantitative data using vertical bars. Right, that I think we just learned that today. That's going to be a histogram. And if we get any of these wrong, then we may have to swap them around later. Okay. A data distribution is blank if the peak of the data is to the left side of the graph, with only a few data points on the right side of the graph. Okay. That one is going to be, so let's see, histogram is done. That one's going to be skewed to the right because only a few points on the right side, and the peak meaning a lot of the data is on the left side. So that's going to be skewed right. Blank are data that have only finite number of values or data that can be counted, right? Counted or only finite. So the word is finite or counted, and that's going to be discrete. Where is it at? Right here. Discrete data. Okay. A blank displays the data distribution based on 5-number summary. Okay, 5-number summary, that's what we did yesterday. That is going to be a box whisker plot. Oops. Okay. The oval shape of a graph, which shows the way in which data are spread out or clustered together, is called a, let's see, continuous, nope. Frequency, nope. Skew left, nope. Data distribution, that sounds right. 5-number summary, nope. Symmetric, dot plot. I think I'm going to go with data distribution. Blank are data which can take any numerical value within a range, and we talked about that today. That's going to be continuous data. It actually should say continuous data or data, but continuous or data. A data distribution is blank if the peak of the data is to the right side of the graph and only a few data points to the left. So this is going to be the other skew. This is going to be skewed left. Number 8. And blank is a graph that shows how discrete data are distributed using a number line. Discrete data distributed using a number line. Let's see. I would say dot plot. A dot plot is a graph that shows how discrete data are distributed using a number line. I like that. For a set of data, the blank consists of the minimum value, the first quartile, the medium, the third quartile, and the maximum value. I saw this one. This is the 5-number summary. Let's see. Right there, 5-number summary. Abbreviate it. I'm out of space. Oh, number 10 doesn't show up. I'm sure it shows up on your paper. A data distribution is blank if the peak of the data is in the middle of the graph. The left and right hand sides of the graph are nearly mirror images of each other. This is going to be something symmetrical or like a normal. Oh, symmetric right there. Really? The number of data values included in a graph included in a given bin of data set is called the frequency. Okay, frequency. Let's see. Number of data values included in a given bin of data set is called frequency, right? Okay. And now that number 10's missing, I'm thinking, what if this was, let me see. Just double checking the continuous. Yes, I was thinking that this right here should say continuous data, but I guess continuous works. But I would like it for it to be continuous data, and that would be continuous data right here. Our data that can take any numerical value within a range. All right, first page. Oops. Second page. Analyze the given dot plot, which displays the number of home runs with each of the girls of the softball team this season. Right, use the dot plot to answer a question. Describe the shape. Explain what it means in terms of the problem situation, right? This shape, if you look at it overall, there's a lot on the left-hand side and a few on the right-hand side. This is going to be skewed right. And what does it mean in terms of the problem? It means that more people, if you think about this, right? Number of home runs, right? So who hits home runs? Everyone? No. Only a few people. So like a lot of people, 4 people didn't hit any home runs at all. 3 people hit 1 home run, 2 people hit 2, and the 2 people hit 4, and then that's pretty much about it. So yeah, I mean home runs are pretty special, and a lot of people don't hit very many home runs. So a lot of people hit low number of home runs. These are the low number of home runs. Okay. High number of home runs, like 7 home runs, 8 home runs, and 12 home runs. Only very few people see that. Only one person hits 12 home run. One person hits 8. One person hits 7. So what does that mean? Right? It means that the more home runs are hit by less people. That's why it's heavy on the left side and it's light on the right hand side. That's why it's skewed right. How many players are on the softball team? Oh, so count 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to say 14. 14 players. How many players hit more than 2 home runs? Okay, more than 2 home runs. That means that we're not even counting 2 home runs. So more than 2 home runs. That means we need everyone that's more than 2. So not counting 2, but 3 and bigger, right? So how many players hit more than 2? 2, 3, 4, 5. So I would say 5 players hit more than 2 home runs. How many players hit at least one home run. So that means that they at least hit one home run. Right? So one home run and more. If you think and you count that, so one home run and more, so it's going to be all of these people here. So 3, 4, 5, 6, 7, 8, 9, 10 players. How many players hit more than one and fewer than 9 home runs? So more than one's what we have here, but fewer than 9 means less than 9. That means that's these right here. So who hits more than one? Oh, let me see. Hit more than one. Oh, so that means I'm already off. More than one would be, so fewer than 9 is less than 9, not counting 9, and more than one is more than one, not counting one. So I'm going to be talking about all of these people here. And you can see that there's an overlap right in here, right there, where the red and blue is. So yeah, 2, 3, 4, 5, 6 people hit more than one, but less than 9. How many players score more than 12 home runs? Just looking at that, 12 more than 12. Only one person scored 12, but I don't see anybody scoring more than 12. No players. Okay. Next one. Analyze the given box and whisker plot, which displays the height of 40 randomly chosen adults. Okay, use the box and whisker plot to answer each question. Okay. What's the height range of the middle 50% of the survey adults? All right. Remember, each one of these section on this box and whisker is 25%. That's 25%. This in here is 25%. This in here is 25%. And this over here is 25%. So what is the height range of the middle 50%? So it ranges from 65 all the way to 72. Okay. So it goes from 65 all the way to 72. So the range is 72 minus 65. And if you use a calculator or do by hand or count, so the range is going to be 72 minus 65, which is going to be 7. So the range of this, if you count 1, 2, 3, 4, 5, 6, 7, that means that they can range from 65 all the way to 72. So they can range in a range of 7 inches. How many of the survey adults are exactly 68 inches tall? $68. It's right here. And we don't know, actually. Okay. How many are exactly 68? We don't know. We know 68 is the median, is the middle, but we don't know how many is exactly 68. Okay, because again, there could be something that's 67 and then 69, right? And then 70 and 70 and so forth and 50. You get the idea. But if we and let's say 47, right? So if we actually found the middle, we cross out the 70, okay, and the 47, cross out the 50 and the 70, and then we're left with 67 and 69, and in the middle is 68. So that's where we get the middle, but it doesn't actually mean that somebody is actually 68, right? So we don't really know exactly if there's anybody that's 68. So I'm going to say it is unknown. How many are exactly 68 inches tall? What percent? Okay, so now we can answer this question. What percent of the survey adults are 68 inches tall or shorter? Okay, again, this was just an example. Okay, so what percent of the survey is exactly 68 inches tall or shorter? So we want everyone that's 68 inches tall or shorter. So we want all of this, 25%, and or shorter, so all the 25, 25. So what percent? That's going to be 50%. Oh, I thought I picked red. What is the height of the tallest adult survey? So the tallest we do know. Tallest, this is the minimum right here. Oops. This is the minimum. This is the minimum height right here. 57. And this is the maximum height. 79. So we know that the tallest person, the maximum is 79. How many of the survey adults are at least 50 inches tall? Okay, we can figure that out. How many of the survey adults are at least 58 inches tall? So 58 is, where's 58? Oh, 58. 58 is right here. Oh, sorry. I might miss my number. That's 58. It's the smallest number. I counted wrong. 55, 56, 57, and then 58. But how many people are at least? That means that the smallest, the lowest, the smallest number they are is 58. And then everyone is above that. So what percent or how many of the adults are at least 58? That's how many of the survey adults? That's 100% of them. Right? That's 100%. Oops, 1,000%. 100% or 100% of 40 adults is 40 people. Describe the distribution data on the box and whisker and explain what it means in terms of the prompt. This one looks pretty symmetrical. Okay, it looks symmetrical. Again, we're not quite sure if it's uniform or we're not quite sure if it's U shape or if it's normal, but we're gonna say it's symmetrical because because it's pretty well balanced. The middle two, right? This side looks a little bit bigger than this side, but you know what? It's okay. I mean, they're pretty close. And then this whisker is pretty much the same size as this whisker. Okay. So at the moment, okay, we're not quite sure if it's normal or uniform or U-shaped, but we're gonna say it's gonna be symmetrical. Okay, this is gonna be a symmetrical distribution. Right, and what does it mean in terms of this problem? Okay, it means that everyone is represented equally. Right? There's a good amount of people in pretty much every category. I mean, it's not perfectly equal. You can see that, there's more on this side and more on this side, and there's less on here. So actually, I mean, if you really want to get down to it, okay, you see how there's more here than there are in here. That means that these are higher and these in here are lower. So this is actually going to be a U shape. Okay, if you really want to know, right? So what does it mean? It means that there are people who are a lot of people who are extremely tall and a lot of people who are extremely short, but there's less people who are in between. Or, well, I don't want to say extremely tall, but let's say there's lots, right? Lots of people above 72 inches tall, and lots of people below 65 inches tall. Okay, and in between there's less. Okay, so that's what you would say here. Okay, what does it mean? It means that um, I would say there's probably the same amount of people above 72 inches tall as there are below 65. There's the same amount of people above 72 inches tall as there are people below 65 inches tall. Okay. Okay, last one. Analyze the given histogram, which displays ACT composite scores of several randomly chosen students. Use the histogram to answer each question. Right? You might need a moment. If you need to, pause this video for a second and analyze this. Okay, how many students are represented in this histogram? We can figure this out. Let's see. 4 students got between 10 and 15, so that's 4. 7 students got between 15 and 20. So 4 plus 7. 9 students got between 20 and 25. 6 students got between 25 and 30. And 5 students got between 30 and 35. All right, so let's say I'm thinking that's 10, 19, plus 7 is 16, and then plus 5 is 10, and that's 16, so that's 26, and then plus 5 is 31, right? So there are a total of 31 students. Describe the distribution data of the histogram and explain what it means in terms of the problem. Right? You look here. See how there's a lot of students in the middle, okay? Which means that a lot of students scored 15, 20. A lot of students scored, actually more students scored 20, 25, and a lot of students scored 25 to 30. So this right here is what we call a normal distribution, right? Okay, and this kind of fits with that most students scored within the 15 to 30 range. And then there's less students scoring from very low, and there's less students scoring very high. Okay, so less students scoring from the 10 to 15, and less students scoring from the 30 to 35. You can also write that in here. I wrote it. Okay. How many of the students had an ACT composite score of exactly 25? Okay, that is going to be kind of difficult to tell. Okay, we cannot tell from there because exactly 25 is a single number, and if we go 25, it could represent anything that's in here, and we don't even know if it's going to be anything in there. So there's 6 students who could score 25, but we don't know because it could be 26, 27, 28, 29, or 30. And then there's also, for 25, there's also 9 students who could score between 20 and 25. So that exactly 25, we don't know. Okay. So I'm going to say unable to determine. We are unable to determine. How many of the students had an ACT composite score of at least 20? There we go. Okay, at least 20. So 20 is right here. So the lowest is 20. So that means that anybody who scores above that. So we need from 20, 25, 30, 35. So we need to use the 9 students, the 6 students, and the 5 students. So that would be 6 and 5 is 11 plus 9 is 20. So we're going to say 20 students. How many of the students had an ACC composite score less than 30? Okay, so less than 30. Again, we could figure that out. Okay, less than 30. So we're looking at all of these right here. So meaning you utilize that 6 plus utilize that 9 plus utilize that 7 plus we're going to utilize that 4. Again, these are 10, 16. 10 plus 16 is 26.